Today I'm here with a new video, and this time I'm covering ZMR chart. Okay, so as you know, IMR chart, which is called individual moving range chart. We also have ZMR chart. So today we'll talk about when to use and how to use ZMR chart. So if you see this graph, you can clearly see when to use IMR chart and ZMR chart when you have the subgroup size equals to 1. I mean, whenever I'm taking one sample at a time, so I have to use IMR chart, but there is a dissimilarities between IMR and ZMR, and a big dissimilarity which I will talk today, and when to use ZMR chart and how to use in effective way. Today we'll talk in that. Okay, uh, let's move on. So IMR chart and ZMR chart. So let's understand when to use when we have the subgroup size equals to 1. You see, in our IMR chart or ZMR chart, you have the I and Z chart, right? I chart and Z chart. So in I and Z chart, mostly we talk about whether the process is centered or not. Process center is nothing but the average. We'll talk about average. And when we talk about MR charts, in both the cases we are talking about the variations, the process variations, how far we are from the average, how far our data points are from far away from the average. Okay, let's understand and more deep dive of ZMR and IMR chart. So first of all, ZMR chart. Now what is the meaning of ZMR and when to use it? Please understand, whenever we are using ZMR chart, in that time mostly we have a very limited amount of data. Okay, and suppose you are running a line or you are running a machine, but in that machine you are always running different products in a very short period of time. So I mean, I'm running product A, let's say, for 1 hour, product B for another 1 hour, product C for 2 hours, product D, and so on. So in these cases you cannot collect lots of data, right? So you will collect maybe 4 or 5 samples from each run. So run A in the sense product A is running, you will take 5 samples. Product B is running, you will take only 3 samples. Product C is running, you will take another 5 or 7 samples. So in this case, the number of data points from each run will be less. So you'll be having limited amount of data points. And as I mentioned, the different run in the same process. So when you are running product A, will be having different mean and different standard deviation compared to the product B and C and so on. Correct. So in these cases you have to use ZMR chart. Last but not the least, mostly we are assessing the short run process. Short run, as I mentioned, when you are running product A for 1 hour, product B for half an hour, product C for 2 hours. So in these cases you will be have very few product, but you will be having wide range of product in the same line. So in these cases you have to use ZMR chart. Comparatively, IMR chart is very easy in the sense I'm running product A for, let's say, for an entire shift, and I've collected 25 samples or 30 samples. Then in the shift B also I'm running the same product. I have collected another 10 or 15 samples. So total I'll be having 25 or more than that samples, and I want to check whether my product, the same product, is stable or not. Correct. But in these cases ZMR, you have the different products, you have the limited amount of data, but still by using the ZMR chart you can check whether your process is stable or not. Okay, let's move on and go a deep dive in this and understand how the control limit is interlinked between IMR and ZMR chart. For IMR chart deep dive, you please watch my previous video. So you can see the upper control limit and lower control limit is nothing but the average of individual data point plus the 3 multiplied by the moving range average, divide by d2. d2 is your nothing but the short constant, which you can see here for subgroup size 2, 1.128. Now why subgroup size is 2? Because in the moving range part we are taking the difference of consecutive numbers. Assume you have 25 data points and you are calculating the moving average. So what you will do, you will take the absolute number of the difference between 2 and 1, between 3 and 2, between 4 and 3. I'll explain you also when we will talk more in the minitab and the Excel file. So for mostly you are taking the difference between two consecutive numbers. So 2, that's why the subgroup size is 2, and the d2 value here is 1.128. Now coming to the moving range chart. In IMR chart, when you talk about moving range chart, it always have the lower control limit as 0. The reason is the formula for the lower control limit is d3 mr bar, and d3 for the subgroup size 2 is 0. So automatically your lower control limit becomes 0. Now let's talk about the upper control limit is d4 and the moving range average. So now D4, now here is your D4. D4 for subgroup size 2 is 3.267, right? Multiplied by whatever the moving range is coming from your data point. So that's how you will calculate your IMR chart control limits. Now let's understand a very big similarities between ZMR chart. Now in ZMR chart, the formula is same, upper and lower control limit x bar plus 3 multiplied by standard deviation. But in the case of ZMR chart, mostly we are converting our entire data into the Z values. I will show you how you can convert those. But if you see these two formulas, you can clearly see the standard deviation of, if I say both the formulas are same, then I will say standard deviation equals to r bar divided by d2, right? Similarly for the lower control limit also I will say the standard deviation will be equals to r bar divided by d2. Yes, you are right. So the formula for the standard deviation for ZMR chart is equals to r bar divided by d2. Okay, now coming to the moving range chart, the formula is 100% same as we have the individual moving range chart. Okay, now let's understand in the Z chart why we called as Z chart. If most of you are from Lean Six Sigma background, you will definitely know the meaning of Z value. So Z value is nothing but, you will say, the value which are converting your normal data points into a normal distribution curve, and which will say the standard deviation is equals to 1 and the average equals to 0. So now the Z value formula is nothing but x minus x bar divided by sigma always. It means you are taking the difference between each data point with the average and dividing it with the standard deviation. So here the standard deviation is equals to r bar divided by d2, which is coming from your moving range chart, right? So you have to understand very clearly, in the Z chart I am transforming the entire data into the Z values, and then I'm plotting those Z values, okay, indirect way. Please understand, when to use ZMR chart, when you have different runs. So I have the product A, product B, product C, product D, and so on, but I have very less data point. Let's say product A is having 5 data point, product B is having 3, product C is having 4 data point. So in these cases what I'm doing is I'm combining all the data points and I'm standardizing across all the data points as a Z distribution or the Z value and checking those into the ZMR chart. Okay, I'll show you how to do it within 1 minute, but you need to understand, when you are talking about Z chart, only the Z chart, I'm converting the entire data into the Z values, and always remember the Z values which will be having the value or the center point, the average x bar equals to 0 and the standard deviation equals to 1. Okay, now coming to the moving range chart. Now the moving range chart, so it means, so first talk about the Z chart again. So it means your average here will be 0 plus 3 into the standard deviation equals to 1. So your upper control limit will be 3 and the lower control limit will be minus 3 always. And if I say the center line of your control chart will be 0, so it means I'm checking the data point between minus 3 to plus 3, and the center line will be 0. I'll show you in 2 minutes. Okay, now coming to the moving range chart. The moving range chart, it's nothing but it's monitoring. As you know, the range is nothing but what? It's a difference, correct? Difference between the consecutive values, or the highest value and the lowest value. But in case of the moving range, it's a difference between the consecutive value. Now when we talk about the ZMR chart, so it's a difference or the variation between consecutive Z values. It's not the I values. Okay, in case of IMR chart, we are taking the difference between the consecutive I values or the individual values. In case of ZMR chart, this is the only difference. We first calculate the Z values for each data point, and then we will take the consecutive difference and we will calculate the range, and then we take the average of those and we will calculate, and by the average we will be having R bar values or MR bar values, right? So in this case, whatever the data you have, whatever the runs you have, whenever you are converting into Z values, I'll show you that as well. Whenever you are converting into Z values and then you are taking the average of the moving range, it will always come as 1.128. The average will always be 1.128. I'll show you within 2 minutes how come it is. Now the upper control limit, you can see the formula here. D4 is nothing but 3.267 multiplied by the moving average, which I'm saying is always 1.128. When you multiply this, your value is coming 3.686. So it means the upper control limit will always be 3.686 and the lower control limit will always be 0. You can see here. Okay, so let's try to understand this with an example. Now suppose you are working in a metal part manufacturing company, okay, and you are a quality manager, and what you want to see or you want to assess, you are assessing the stamping process. Okay, now the parts measurement were taken from the three runs means run A, run B, run C. Now three runs means you have three products, you are running the product A, product B and product C, and you are checking the stamping process. Because each run was a short duration, as you know, in the ZMR chart we are talking about the short duration, and a limited amount of data was collected. So from run A you can see you have collected few data points, from run B you have collected 5 or 6 data points, similarly from run C you will be having some data points. So as an engineer, as a quality engineer, you want to use this data to check the stability of the stamping process. How you can check? Now please understand, I cannot use IMR chart here because your products are changing. If you have a similar product running entire day or entire shift and you are having all the data points from the similar product, you can use IMR chart straightforward and go ahead, okay, whether controlled or not controlled. Okay, but in this case your products are changing, so you have to use ZMR chart. Okay, first I'll show you how you can use it in minitab and then I'll elaborate this through Excel. Okay, let me just go to the Excel to copy and paste the data first. So as I mentioned, you have these two data points, these two datas. One is for how many running you have and then the data points, right? Let me just copy and paste the data. So if you see this data here, so you have run A, go down run B, right? And then you have run C for the stamping process, right? Now how to use the data or how to use these in minitab? It's very simple. Just go to stat, go to control chart, and the control chart for the individual for variables, and you have the ZMR chart. Click on this. You have the variable, put this stamp part indicator runs, and as I mentioned in my other videos for IMR or X bar chart, always use this ZMR or IMR or X bar R options button. Click on this and always try to store your plotted value, center line value and control limit in your worksheets, because you can check whatever you are getting in Excel or whatever you are getting here is matching or not. Okay, when you click all these, click OK and OK. When you click OK, it will give you a graph and it will give you, let me just minimize this, and it will give you all your information in this window. Okay, right, so all this information I'll show you how you can get it in Excel as well. So let's understand this graph first. Now if you see this graph is having two parts. One is your moving range and then you're using your standardized data or the Z values we call as, okay, or Z chart. Now as you know, whenever we talk about IMR, X bar R chart or X bar S chart, in my previous video I always tell you, please use or please see MR chart first. If it is in control, then only go ahead with the Z chart or X bar chart, because your X bar chart or I chart or Z chart here will always come from your MR chart. Okay, it cannot be plotted just just by the Z values, right? So you have to use your moving range chart. Now if you see this entire diagram, it's split into three parts: run A, run B and run C. So these are the moving range values and these are the values of the Z chart. Okay, and as I mentioned, you have the upper control and lower control limit. See here, always whatever the data you will be having, your lower control limit will be -3 and upper control limit will be 3 and the center will be 0. Why it is, I already told you. Now come to this area, you have the lower control limit as 0. You know why it is. MR bar is always 1.128. as I mentioned, whatever the values you will be having, your moving range average will be always 1.128 and the upper control limit will always be fixed 3.686, because these values are coming from your Z values are connecting. Okay, so these upper lower control limit and the central line for ZMR chart is fixed, but it is not fixed for IMR chart or XBAR chart. So that's the biggest difference. Okay, and now by looking at the data, it's looking very good. Both the graphs are in control, so you can say yes, your process is stable. Now try to understand these values, from where these values are coming. You can see the value number 1 is 1.147, the value number 2 is 0.018, and so on, correct? So how these values are coming, let's understand and in the Excel file. So I've created a very simple Excel to explain you in detail. Okay. So first, please forget all these part. I will come one by one to these numbers. So whenever you have having these kind of data and you want to use ZMR chart, the first and foremost thing is you have to calculate your R bar, X bar and the sigma values. Okay. So for calculating the R bar values, so you should know the range. So range is nothing but it's a difference between the consecutive number and say absolute number. It cannot be negative because it's a difference between the highest value and the lowest value. So whenever we are calculating the MR or the moving range, it's always the first value will be nothing because you don't have anything before that. So for the second value you will be having, you can see the formula, this minus this and the absolute value you can see here, and so on. Similarly for the run number B and run number C, you can see here, right? So what I did is for run number A, I took the average. If you take the average of run A, you can see here 2.075, which I mentioned here in this area, 2.07. Similarly, this is the average for run B, average for run C, correct? And now you have the X bar value. Now what is the meaning of X bar? X bar for run A. Run A is here, you take the average for all the run A's. You can see the average here on the bottom, you can see 300.52, which is here, right? So this is the average, this is the average, this is the average for run A, B and C. Now the last and not the least is your standard deviation value, because this standard deviation value only will give you the Z values. Now how to calculate the standard deviation value? You know the R bar divided by D2, and D2 value is here, right, in the short 1.128. So what I did is for run A, I know the R bar value is here, right, 2.0 divided by 1.128. So you can see both are matching, right? So I have calculated the sigma values for run A, sigma values for run B and C. Now if you have this information firstly, then you can calculate your Z values. Now what is the formula for Z value? You already know the formula is X minus X bar divided by standard deviation. So what I did is I just use this formula. So this is your X value, first value, minus X bar, you already know for run number A is 300 divided by your sigma value, which is 1.84. So I use this formula for all the value of run A. Similarly, if I go to run B, I will take the difference between this value and the average of run B and divide it by the standard deviation, and so on. Similarly for run C. So when you took all these values, so these values is nothing but these values are plotted here, you can see. So the first value is 1.147, which is here. The second value is 0.018 and so on. Now what is the meaning of this 1.147? Please listen to me carefully. This line is very important. So the meaning of 1.147 is your data point, which is 302.63, is 1.147 standard deviation away from the mean. Okay, let me repeat. So your this data point 302 is 1.147 standard deviation away from your mean. So here in this diagram, if you see, your mean is 0 and your standard deviation is 1. So I will say your data point of 302 is 1.147 standard deviation above the mean. Similarly, you will be having these value minus, you can see minus 1.301, which will be somewhere here, right? So in these values you will say UR, or your data point of 298 is 1.301 below the mean, below the center, below the average. I hope you understood this point. So that's how your Z chart will come, and it is coming from your R bar values. Okay, so that's why always you have to check the R bar. or the range chart. Now come to the R value. It's very interesting. If you remember my point here, which I mentioned. So whenever you are calculating the MR chart for ZMR charts, the MR chart is coming from the difference between the consecutive z values you can see here. So you have to calculate the R values now for your R chart. So which is the difference? So here if you see, this is the difference between these two, then this is the difference between these two, and the absolute number, it can't be negative because it's the range, always a higher value minus the lowest value. Similarly, if I go here, this is the value. So if you see here in your R chart, the first value will be nothing, always it starts from the second value, which is 1.128. Let me show you in the mini tab. This is the value, right? You can see here the observation to moving range is 1.128, and so on. Similarly, if you see for run A, observation number 8, the moving range is 2.005. If I'll go here, this is the value. So this is the value, observation number 8. If you count from here, so this is your if you count from the top, this will be your observation number 8. You can see, so from here to here, so this is total counting is 8. So the 8th observation, which is 2.005, and so on. So this is how you will get your R values. Okay, so ZMR chart, now you understood why it is very important, because it will not only calculate your Z values or MR values, but it is very important when you have less number of data points and when you have wide varieties of product. In this case I have taken 3 products, maybe you can have 4, 5 and so on, and you can check whether your data is stable, your machine is running perfectly fine for all these products or not. And even suppose sometimes you will be having, let's say, product number B is not good, sometime product number C for some time is not good, so this chart will also show you those. Okay, so I hope you understood how to use ZMR chart.